Going to be a bit untypical for most of you because I think this is something which you will not have the chance to do many more times. Today involves a type of thinking which probably you're not familiar with, which is more philosophical, more deductive, more discursive. Okay, so it will be, I guess it will be a bit challenging and it will be very dense, but I will still ask you to kind of follow me. There's going to be a lot of space for you to talk and we need to make this together. You will see today there is a lot of content. There is a lot of terms, there's a lot of new words, there is a lot of new paradigms, there's a lot of new authors and all of this. In order to survive, I suggest 3 practices. First, the note keepers focus on trying to capture what the class says. So who are note keepers? Okay, all right. Focus on trying to capture what the class says. The slides will have a bit of a more key points of what I'm saying, and it will be a lot of reference readings. So maybe try to capture more what comes from the class and what comes from this type of discussion. Second point, for those of you that are attending, don't expect to be able to open the slides and just come to the exam, because in the slides you will not find all of the information. You will need to integrate it with your own reasoning, what is written in the notes, and what is in the readings. Okay? So try to capture what is here, try to understand the high-level reasoning of what is here, because in the exams we ask you questions which take the same reasoning, and we reward if you come with your own ideas related to these topics. Okay? For the non-attending students, you can follow and enjoy the lectures, and the non-attending student, we just tell you there is one mandatory reading for non-attending students in this class. You read the mandatory reading, you kind of understand it. If there is a question on this topic in the exam, you will be able to answer perfectly. Okay? So this is just 3 practice to survive the next hours. Doubts? Questions? Okay. So, today's lecture is called Epistemology of Computer Science, of ICT if you want, even better. So let's start with asking, what is epistemology? What is this about? Even high school definitions, we don't require any rigor, just try to understand what this is about. Yes?
Something related to knowledge, like how we acquire it and how we, I guess, between truth and facts.
Okay, it's something related to knowledge, acquiring knowledge, truths, facts. Okay, this is good. What branch of what subject is epistemology of? Is it a branch of medicine or philosophy? Okay, so it's a branch of philosophy that is involved with knowledge, with truths, with facts, and also with what? If you want to have other definitions, other tidbits. So I will usually not continue unless I hear something from you. There is a lot of time, so I have time, so you have as well. But if you want to just be brave, it's better, it makes it faster. So, philosophy of knowledge, of truths, of facts, and of what? There's at least one point which is missing.
Justifications.
Justifications, yes. One more, even bigger. Concepts? Okay. Science. Epistemology is also philosophy of science. Okay? So it's the level, let's say, which is above all of the procedures, all of the theorems, and all of this is how we acquire, how we manage, how we shuffle, how we search, how we construct, how we verify, how we falsify, how we knowledge. Okay? So, do you think there exists in the world one epistemology? So, is epistemology an abstract entity which applies to everyone? Yes? No? Why? Or, let me put a different question. Does a farmer acquire knowledge in the same way that a doctor does? or a computer science scientist does, or an engineer of telecommunication does, or a physicist does? Yes, no? No. Why? What makes it different?
The environment where you are, the experience that you have.
Their environments where they are. So the space in which they operate. Yes, environment is one of the keywords. We decided to remove it from this lecture, it was the title of this lecture when we first started doing something like this. But we removed it because when you said environment, people were thinking about trees and saving the planet. So the environment in which you are is a big difference, yes. The experience that you have is different, of course. The cognition, so the perception of the space around you that you have is different. What else? Does a farmer use, if you compare, I don't know, give me the example of two different professions that work in the same field.
Designer and developer.
Sorry?
Designer and developer.
Designer and developer, perfect, thank you. Does a designer and developer, I assume for a software, acquire knowledge in the same way? So the environment is the same. The knowledge is different, the previous experience is different. The cognition is pretty much the same in the sense that they have the same type of eyes, ears, and so on. But do they acquire and they manage knowledge in the same way or not? No. If a designer wants to do his job, what will he use as his source of knowledge? Will he use a book? Will he use the world? Will he use his previous experience? Will he use the work of somebody else? Of course, a combination of all of this, but what will he use? And what does a developer use? So if I'm a developer and I want to write an algorithm, do I start looking for how to build an algorithm by going in the world and picking up grass from the ground? No. What do I use?
Relevant content.
Relevant content, which is relevant why?
Because it's according to his own field.
Yeah, it's a content in the same field. It's something which is connected to what I'm doing. Maybe it's a work of somebody else which applies the same logic, and I want to adapt to the context in where I'm working. This is 90% of development work. Taking something which is already there and trying to make my own version of this, right? What about the designer? Does a designer do the same thing? Also from this part, I need to move here so that the people from here will start responding. Does a designer do the same thing?
Yes, more or less.
Yes, more or less. Why?
Because, an example, if you design an Android app, you try to reuse some patterns that the final user know because they have previous experience from.
So, there are even more, this is a very good example. You use the same design guidelines, the same design patterns, right? But if I'm a programmer and I'm doing back-end code, typically I'm not just using the same pattern, the same guidelines. I'm using the same code. I'm using the exact same knowledge. So there is a different level at which they use a common knowledge to work. And there are different levels of rigor that you need to apply when you're in your own making and understanding and searching for knowledge. If I am a farmer and I just want to manage my field for me and Andrea and I don't know, we are a family, okay, I have a family of 4 kids, I just want to manage my field, the level of rigor which I need to apply to manage my field and the knowledge which I need is very ethereal. If I have 100,000 acres and I'm producing, crops for a whole country, maybe I need a bit more specific knowledge, right? So there's also different levels of formality, of rigor. Okay, so why do we care about epistemology when we're talking about innovation? What are the similarities or the points of contact between epistemology and innovation? And what is the epistemology of innovation made of? What is it about? So the epistemology of computer science tells us how we can find good patterns to write code. The epistemology of design tells us what are good patterns for engaging and having better interactions with a UI, for example. What is the epistemology of innovation about? Yes?
Maybe a good pattern for good innovation.
Maybe patterns for good innovations, patterns for successful innovations, patterns for innovations that stick into the market. What else?
Maybe patterns which lead to this innovation, not only the innovation.
Patterns which can help us find new innovations. Also, even patterns that can help us find patterns. Okay? Very abstract, very meta if you want, but this is also there. Because we can use the same, we can define ways in which we look for innovation, in which we construct innovation, and use them to apply for new innovations. Okay? So there is some contact. And what does epistemology have to do with decision making? This is the last keyword of today, from a macro perspective. And what is decision making? Yes?
Patterns that we are finding will help us to make a decision.
Yes, with the knowledge and the patterns that we acquire, they inform us our decisions, right? So, what is decision making about? Decision making is about, okay, taking a decision. What does this mean? What does taking a decision mean? Yes?
It's like choosing the best choice out of the very many options.
It's like choosing the best choice out of a set of options. Well, sometimes it's also about choosing the worst, or choosing any, or choosing none, or choosing all. But it's about making a choice among a set of options. And this choice typically has one feature, which is that if you take one choice, you cannot take another at the same time. So there is a level of exclusivity in the decision making. Can you give me examples of decisions of any type, sort, formality, informality, field, whatever?
You decide university.
Choosing your university. What else?
Choosing who to vote.
Who to?
Vote.
Who to vote for. Choosing who to vote for in an election. What else? I have a great problem every morning, which is what do I wear? Right? This is also a decision-making process. What else? If you go to the Mensa, you need to decide what will you eat. Sometimes you need to make more critical decisions, like if I am in a startup and I have 4 founders, who is the 5th person I should look for? And who should I hire among a set of possible recruits? So, we will be talking a lot about decision making today. And I put here the first slide, which has many words, which is probably also to be one of the last. But these are things that I would like to focus with you on today as we talk about decision making. I would like to focus on the type of decision making process. So is it instant? Does it take a lot of time? Is it linear? Does it have many opportunities? Does it only have one opportunity? What is the type? How difficult it is? Can I do it like this, or do I need to take 10 days to make a decision? Can I find an optimal? Can I not find an optimal? Is there the candidate to hire, or is there a set of candidate to hires? Who is allowed, is not allowed, can or cannot use the decision process? If I take a very complex procedure and I acquire, okay, let me take the note keeper here, all right, and I tell you the decision-making process. The decision that I need to take is I want to put into a search engine, I don't know, where can I buy a nice jacket, okay? And you perform this algorithm by hand, taking all of the websites of the world indexed in the Google database. Can you do it?
No.
No, no way. So we will see that there are some things that some people can do, some things that some people cannot do. Hiring policy, maybe the last employee does not have the ability to do this decision making. Okay? So we will see who can and cannot use a certain process. We will see why we want to use one process over another. Because when you enter into MediaWorld and you need to buy a shitty SD card of 16 gigabytes, maybe you need to have a decision-making process which gets you out of the MediaWorld in 10 minutes. Because if you need to compare all of the SD cards stored in the MediaWorld, you'll be there for 3 hours. Okay? So why do we use a process over another? Finally, we will do the critique. And I put the brackets and this word with the K because it's the word used by Kant, which is a German philosopher of the 17 and 1800s, which says that critique is the systematic search of the limits. So finding where decision-making processes don't work. How do we break a decision? How do we break a process? How do we make it not work? Special casing, finding edge cases. We do unit testing on decision-making processes. Okay? Why is decision-making critical in business? Because your course is innovation and business. We have seen the innovation part. Now let's look at the business part. Why is it critical in business? What happens if I fumble one of these things in a business decision? I lose money, or I lose other resources. I lose time, I lose people, I lose investors, I lose network, I lose technologies, I lose market share, right? Decision making in business matters. For what else?
Maybe it's not about losing, it's about not gaining something.
It can be about not gaining. On the other hand, it can be also about gaining, right? Doing the appropriate decision can get you there. What are also other things in business where decision making you think is crucial? What are edge cases of business decision making which I think are particularly tricky? So when we are taking a decision, we are not taking it for now. We are taking it for the future, right? Because otherwise it would be quite useless. And when we are looking at the future, we have some sort of an outlook in the future of 1, 2, 5, 10 years. What can happen in terms of decision making and in terms of outlooks in the future?
Legal aspects of the business.
Sorry?
Legal aspects of the business.
Legal aspects of the business, yes, but let me give you an example of decision making informal, and you tell me, you, plural, tell me a parallel in business. So if I am going back to my dilemma of every day, which is choosing my clothes, right? And today I decide that I wear a black t-shirt, a black sweater, and beige pants, okay? And I stick to this decision for the rest of my life. Is this a decision optimal? No. Businesses do not only need to make decisions, but they need to adapt them. They need to change them. They need to understand when their processes are leading them into pitfalls. Can you give me examples of this? Big case studies, big examples of decision making going wrong in business in this terms of short scale, long scale, or pivoting in decisions? So I can see now a company from this room which did a big pivoting in their decision making. And it is within the radius of 1 meter from me.
Data protection laws, and then GDPR
Okay.
came.
Where is the data protection law and the GDPR within 1 meter from me? No, but it's okay. Go ahead. Please explain.
Well, for example, if you have a company and these data protection laws are not really defined properly, but then in the future, government emphasizes you to keep eye on these legal aspects of data.
Right. So if in the past I had a more lenient legislation which allowed me not to worry too much about the protection of the data of my users, and I stick to the decision making and to the procedures that I had before, and then GDPR comes out, I am lost because I will get sued by everybody in the world and I will lose a lot of money. But I want to point you to one company which did a big change in their decision making. What is the big change in the decision making? What are big decisions that Apple pivoted on?
Go from computer-based approaches, so produce to a mobile-based system.
Right. Where is this reflected the most in the Apple structure?
Near everywhere.
Okay, even more clearly, in their name. Up until 2011, they were called Apple computers. In 2011, they're just called Apple. Okay? Right. What else? What are big decision shifts in Apple's history that you can see? I can think of 3 more. Let's see. IBM? What do you mean?
They also were making computers, and now they are more into, I don't know, research.
Okay. IBM used to be a company that was making computers. Now they're more consulting, research, and so on. There is something related to IBM and Apple. Apple used to have IBM processors until 2007. Okay, the PowerPC architecture. In 2007, they just said, oh, and they were saying that IBM was so much better, and this architecture was so much more effective, and actually it was, because it was 15% better at the same clock speed compared to the Intel architecture. In 2007, they said, great, no more IBM, now everything is Intel. Okay, big pivoting in the decision making. What else? The CEO, Steve Jobs, was fired by Apple. You know this? Who knew that Steve Jobs was fired by Apple? Okay, so why was he fired by Apple and when? Maybe the backside of the class?
Was it in the 90s?
It was in the 90s, yes.
Yeah.
More or less, why?
He was not, he didn't agree with their policies.
Yeah, he didn't agree with some policies, and especially he showed some critical mistakes in the managing of some products. Which ones? The ones that were not computers. The Next, and the how was it called? The PDA that Steve Jobs was a big promoter of. There was a PDA, is a personal assistant, the personal device assistant, which was something like a smartphone in the late 1990s, actually even in the early 1990s. It was something that had a calendar, it had an agenda, you could put notes, you could put reminders, alarm clocks, right? In a small device that looked like a calculator. He was pushing a lot all of these, but it didn't work too much. The Newton also wasn't, the Newton was. Steve Jobs was fired over this. Fast forward 10 years, they hired him back. Okay? So, but they hired him back with a salary of, you know this? What was the salary? $1 per month. This was the salary of Steve Jobs. So how did he make his money, by the way?
He owned another company.
He owned other companies. He had shares. Yes. Okay. So, you understand why decision making in business is important, because when you take decisions, an ability to reevaluate decisions can lead you to success, to failure, to new opportunities, to less opportunities, and so on. And how does decision making connect to ICT, finally? Because innovation and business in ICT. So, I gave you one name, and I will ask you to raise your hands if you know this name. Herbert Simon. Okay, let's try with another one. Let's try Alan Turing. Okay, so so we will get to Herbert Simon later. But Alan Turing, who does not know Alan Turing, first of all, which is fair enough. Okay, at least one person. So this is a moment, this is going to be a transformational moment for you, because I will tell you that Alan Turing is credited to be the guy that invented computer science. Okay? And why was he the one that invented computer science? Yes, which how does it work? The Turing machine. What is it about? How does it work? Are you taking a course of computability? At least here, at least one person is taking a course of computability. Brilliant. So can you tell me informally what is a Turing machine? Also if you want formally, but that might generate even more confusion.
Just use it to model competition.
Sorry?
Use it to model competition.
I cannot hear you. You need to speak very loud.
Use it to model competition.
Okay, Turing machine is used to model computation. All right. What is it? How does it work? What it is about?
There is a tape.
Okay, there's a tape which is how long?
Infinite.
Infinite. Okay,
Both sides.
on both sides. And what does this tape contain?
And there are alphabets,
Mm-hmm.
which are symbols.
There are alphabets with symbols that are written on this tape,
Yeah.
right? And in modern computation, this is mostly an alphabet made of how many symbols? 2. All right. Okay. And what can this machine do? Well, okay, there is a tape, and then what happens?
Just it works like that. There's a head.
There's a head.
Yeah.
Okay.
It's required to program answering.
Which has some memory or some internal 2 registers. Okay. Which what does it do? Very high level. But don't need to go too much into detail. At least it reads and it writes on the tape. Okay? It performs operation. It reads operation on the tape and performs operation on the tape. Okay? Find instructions, run them, then execute the output and store the output somewhere on the same tape. Okay? Turing defined the Turing machine. If you have better definitions, you have to intervene, not sleep. Okay? There is still 75% of sleepiness in the class, which we need to remove by the end of the hour. Okay? So, if you have better definitions, contribute. If the definitions are not good enough, you will complain in 2 months' time because in the exam you will say we don't have good enough definitions. So, contribute. Okay? Turing, the Turing machine. Then, what else? Still with Turing. Sorry? Enigma, yes, which was the cryptographic bomb, not the Enigma, but the cryptographic bomb. So the decryption of the Enigma code, which was the code used in the Second World War that the Axis was using to communicate, yes. What else? There's one big contribution of Turing, which is quite relevant nowadays.
Turing test.
The Turing test, artificial intelligence. Yes. So what was the reasoning of Turing, and then what is the Turing test? If you want to.
What was the Turing test? It's a test so where you have from one side the computers, and from the other side a human person, and with this test the people from the other side must not understand that it's not speaking with another human, but with a computer.
Okay, let's put it in another way. You have a person in front of a computer, okay, typing messages to someone, to another actor. The Turing test stages this problem. The person which is typing these messages needs to understand whether the person that he's typing, the actor he's typing the messages to, is a human or a machine. If, after a certain, potentially unlimited amount of time, he cannot decide whether he is speaking with a human or with a machine, if it was a machine, the machine is said to be intelligent, indistinguishable from a human. This is the Turing test. So what is the idea of Turing about machines and artificial intelligence by abstraction that you can take up here? That these machines, first, they are capable of intelligence. One of the features of intelligence is being able to take decisions, right? And to take decisions which are not just specific, but are general, based on the context of dialogue. Dialogue is a complex problem, okay? And we will connect this to ICT because you will see, from the reading, that the first name that I said that nobody knew, but fair enough, which is Herbert Simon, is at a distance of one co-author from Alan Turing. So you can find one common co-author between Herbert Simon and Alan Turing. And actually all of the artificial intelligence field starts from Alan Turing and Herbert Simon. And all the decision-making theory and all the game theory starts from here. Not all, but let's say a big part of the modern game theory starts from here. Okay? So this is very much about innovation, about business and about ICT. So, in this first part, in this next 20 minutes, I will give you some historical perspectives around this idea of decision-making, of epistemology, of making sense of knowledge, finding knowledge, taking decisions, and so on. Okay? These are related to some words, which let's see. So let's do like this. I'm putting some words there. If you have heard them, you just raise your hand for a second, okay? So that I can see. So, objectivism. At least heard at least once. Okay, a few. Good. Positivism. Okay, many more. Okay. Determinism. Okay, still up quite a bunch. Rationalism. Okay. Romanticism. Okay. This part of the class is really okay. We'll need to work more with you. Modernism. Okay. A bit less, but okay. All right. What do you think these words have in common? Sorry? ISM in the end. Yes. Good point. There is a reason. By the way, do you know that there is this discussion that the 1900s are the centuries of isms? You know, this is what they say. So many of these words come from those days, of course. So what have these words have to do with common? Or can you define or give some high-level understandings of what these words are? Any of these?
They relate to some cultural, philosophical movement.
Okay, they all relate to a cultural, philosophical understanding and movement. Is there a specific, does this cultural and philosophical understanding have some common features, or are they all about different ones? Yes?
All are about the society.
All are about?
The society.
Society, yes, and they also have a certain vision in common, which is which one? So over here, do you see space for anarchy? Starting from these keywords?
Rules.
What?
They have rules.
They have rules, they have rigor, they have a sense of scientific or orderly connotation. Okay? So, objectivism refers to the fact that there is a truth which is out there. It is objective. I can find it. Once I can find it, nobody can falsify it. It's objectively there. I can say that, well, can I say it? That objectively there is a table here? Maybe, but okay. We can say quite objectively there is a table here. We all agree on the fact that there is a table here. Positivism is the idea of science reigning supreme. Science being able to discover everything, being able to understand everything. Determinism, everything is predetermined. Even if a meteor is about to come here and kill me, this was already all pre-written. It might surprise you, but it does not surprise the cosmic order of things. Romanticism, the human mind being able to conquer everything. This has nothing to do with romance, okay? Has nothing to do with going on a date. This has everything to do with the idea that the human mind can conquer everything. Romanticism is the painting of the man over the cliff looking triumphantly over the clouds, which are limitless but all below his gaze, right? Rationalism, role of reason. And modernism, after the Industrial Revolution, man taking control of everything and being able to handle everything. Everything is new, everything is modern, everything is controllable. So, there is one word that comes out of this, which is certainty. A common word. And this is going to be the first of 3 paradigms that we will see today. So here, there is a small grayish thing with a suggested reading. You're not supposed to read it now because you will need to do this, which is not the best. Okay? But what this means says suggested reading. Suggested reading means we think it's interesting and we think it reflects quite well what we're saying. If you read it, it's probably going to be interesting for you as well. But we will not demand that you know this. It is a suggested reading. Okay? So, certainty. It just works. Okay? It's clear, it's certain. What does certainty tell you? How do you think a world of certainty looks like, and how does a decision of certainty look like? So can you give me an example of certainties in your life to start from?
If I don't study, I don't pass the exam.
Okay. Is this a certainty or is this a risk? But, okay, what else? What are other certainties in your life?
Death.
Sorry?
Death.
Death is a certainty. This is interesting because, I mean, to me, the first thing would be, well, I am alive. This is a certainty. Okay, for now, I am alive. But everybody, the first thing that they say is death is a certainty. Okay, there's another certainty which is taxes at this point, all right? Aside from death and taxes, what are other certainties?
Also, taxes.
Taxes in Italy can be a bit of a less of a certainty, unfortunately. What else? What are certainties? So, if I construct a mathematical proof, okay, and it's a mathematical proof to, I don't know, check the validity of SAT, okay? So satisfiability problems, right? I have a specific thing that tells me I have rules that tell me if this thing is satisfiable or not. If I run this multiple times, does it change the outcome? Who thinks yes? Who thinks no? Okay, why yes?
I mean, if you
It might not convert.
no, I mean if you write a mathematical function and you run it multiple times, you have a margin of error that can lead to a different result.
Yes, but if I have a procedure to verify if something is satisfiable or not satisfiable.
You may also change, let's say, how you define something that is satisfiable.
But
or not.
if I agree on the definition, this was the point. I agree on the procedure, I agree on the definition. I take the same thing. Can it change the outcome? Can something be satisfiable today and not satisfiable tomorrow if it is the same? Verify with the same procedure, with the same definition?
Well, in this case, maybe yes. But I mean,
How?
it depends what are you trying to understand it is. If it satisfies you today and tomorrow.
Okay, I think because I was maybe assuming, did you take the course in computability?
No.
Okay, right, so this is why the example is too exoteric. I spare you all the detail. But it's the example, I did a bad example, I took a bad example. So let's take another example. What are certainties according to you? you can come up with better examples than me quite clearly at this point. Certainty, yes.
Things that we've seen over and over many times, and so we were not certain, but the more and more we see these things in time, the more we'll get certain about the outcome.
Okay, let's pin this on here virtually, and let's keep it for later, but for now it's good enough. Things that we have observed for a number of times, and we have seen that they always keep a behavior. There is induction fallacy, we have discussed in the first time, but let's assume that we are not in induction fallacy scenario, and let's say that for now, certain things that I just see, it just works, that's it, right? Okay.
The sun rises early.
The sun rises from the east. I'm not expecting the sun to rise from the south or from the north tomorrow, it will always rise from the east. Okay. Certainties. So, let's do one thing like this. Since in the other class I talked a lot about dating, we had a long discussion about dating, but let's do this. I want to take my date to see the sunrise tomorrow. Okay? Where will I bring her? Will I bring her to something that faces the east or not? Yes? Right? Okay. If I don't bring her to the east, she tells me, you're a fool. You are supposed to bring me to see the sunrise. Does the decision-making process of me taking my date to see the sunrise to the place that faces the east, does it change every day? Is it a difficult process? Yes?
But in the philosophy of silence, I think it's not a certainty, it's a hypothesis.
Okay, what you are saying is fair enough. If you take this from a high level, if you introduce subjectivism, you should say that this is not a certainty, this is a hypothesis. This is a hypothesis based on my cognition. This will leave for the next lecture. For now, we are saying we are in modernism, we are in positivism, we are in rationalism, so this is a certainty. Reasonably so. For today, this is a good enough certainty. So the question is the decision-making process of the place to look at the sunrise, is it a difficult one to find a place? No, I just take any place that looks at the east, it's done. No decision to be evaluated. I might choose a nicer one, a less nice one, but I need to look at the east if I want to see the sunrise, right? No space, no margin for mistakes. So, can you give me another decision of certainty of this type, where it's just this way, that's it, no other options.
Fire burns.
Fire burns, right? You don't put your hand into the fire, it's a stupid decision. The decision should be you do not put your hand in the fire, because fire always burns. So, the process is instantaneous, okay? And it's a line. I have a preference. Okay, these are the words that you will find in decision theory. I put them here, but we can discuss them colloquially, staying at this high level. But we put them here because when, not if, but when you will go deeper on this, you will see again these words, and you will have at least a high level grasping of what this is all about. So, I have a preference. I want to bring my date to look at the sunrise. And I formulate a goal. The goal is, I need to find a place to look at this, which looks at the east. This leads me to an action. The action is, let's put the backpack, let's hop on the bicycle, and let's go to a place which has this site. And this site have a necessary consequence, because the sun will rise from the east, and we will enjoy this. Okay? Because this, we satisfy our initial preferences. Is there margin for error?
Yes.
Yes? How?
Because I'm doing the hypothesis that I am in the certainty domain.
Exactly. This will be our key point of discussion in 5 minutes' time. I am assuming that I'm in certainty. But unless I am not in certainty, so unless I'm mistakenly thinking I'm in certainty, is there margin for error if I am in certainty? No. Decision is instantaneous. So, to put something, does somebody know these pictures? Is there at least one person that has played this game, Anti-Chamber? Disappointment. Okay. Some paths are straightforward. Then there is a level of we add a little bit more subtlety. Let's talk about risk, okay? 60% of the times it works every time. Okay? What is a key feature of risk? If you think of certainty, if you go into a casino, you are taking risks, right? You are gambling. But what is the first decision that you have to take when you enter a casino?
How much money I want to spend?
How much money you want to spend? Okay, let's see if I have another decision. Sorry? Yeah,
Buy coffee.
what?
Buy coffee here.
Buy a coffee, okay, that's a good point. The beer I would not recommend, but because I need to reach the key decision when I enter a casino, which is,
There is no certainty.
okay, there is no certainty, there's a lot of risk, but there is one thing which I have to do when I enter a casino. One fundamental thing.
Bring money?
Sorry?
Win money?
Bring money? No. With? Win money? No, there is one more thing which is super important. What?
Open the door. Open the door.
Open the door? No, it's like turn around and I walk out because I am going to lose on the long run. The house always wins. It's a casino, they're a business. I should not be stupid and play in the casino, right? This is the first decision. And unless I'm a fool, this is an instantaneous decision because I know that the game is rigged against me. But I might be still be willing to try this because I know that since I'm paying a risk and it's still a fair roll of dice, so the die is weighted against me, but I know the probabilities, I might win.
So the decision is to go or not to go?
Well, the decision for me, the first decision in a casino is to walk out. But the point was to say, I can decide to bet, as you were saying, but I bet knowing the probabilities. I bet knowing what are the risks of the game. I know them for sure. I know how many slots the roulette has. I know what are the probability for the slot machine to work. Yada, yada, yada. I know everything. If the casino doesn't do this, they're an illegal casino. We don't want to deal with that. So, the decision making of the casino is pretty similar to the one of the certainty. There is only one key difference, that the consequences have some probability. They're not necessary. In the long run, the consequences are necessary, because in the long run, I'm going to be broke, no matter what. But each atomic decision has necessary consequences with some probability. Because I know that I might win 60% of the time, lose 40%. Okay? So, if I'm taking risks, and I know the risk factors, is the decision making difficult? Yes, no, when yes, when no.
If the risk is high, decision is very
If the risk is high, the decision is difficult. Well, there is one more thing that you need to put. If the risk is high and I have limited resources, then the decision is difficult. Because I'm just asking myself, do I want to try this gamble, knowing that I might lose, or not? If the risk is high, and I have unlimited resources, I will know with absolute certainty whether I should take that decision or not. Right? So, consequences with some probability. But once I know what are my limits, the decision is immediate. Tricky limits might imply tricky decisions. So, another picture, but I'm really sorry that nobody... This is an amazing game, by the way. You should really all play it. It's one of the best of the last 10 years. Choices are just bet or don't bet. Finally, let's look at the biggest bucket of today. Uncertainty. So, you might think uncertainty is just take certainty, put a knot, done. There is a little bit more to it, okay? So, what we're saying is the truth is out there, it's up to you to find it. So what does this quote and this word uncertainty tell you? What does it make you feel? Okay, something which is not certain, but deeper than this, because risk is also not certain, right? By definition. But try to think of what could happen, what could be even stronger than risk. When you are going to buy a stock in the stock exchange, this is risky, okay, because there is some probability of winning, some probability of losing. But do you know the probabilities? No. You don't know the probabilities. There is a level of unknown. So, what can you do? Why would you still buy stock in the stock market? Why would you still take some actions if you don't know the probability?
You can kind of look at how the stocks have been going in the past, so you can make a prediction.
Right. I can look at how things have gone in the past, and I can try to make predictions. I can assume that there must be a logic behind how the things are moving. I can look at the past things, at the past patterns of the stock. I can look at what is happening in the world, and I can make guesses, I can make predictions. And these guesses and these predictions are going to tell me, if you want, are going to help me to reduce the uncertainty I am navigating in to a risk, to something which I know that in the next month, 60% of the times the stock price is going to go up, 40% of the times the stock price is going to go down. Let's buy this, right? Or let's not buy this. So, I need to look into the past and I need to search. Is this an easy process? Not really. Because we will see another thing later. When things are easy, everybody can do it. When everybody can do them, nobody can gain money out of them. Okay? Sounds very stupid. But you will see that a lot of the economics and a lot of the business of this is starting from very much common sense principles. So, if this were easy, everybody would do it. Okay? But it is not. Because you need knowledge, of course, to understand the patterns and so on, but you also need something else. What do you need? To crunch all the numbers. Once you have the numbers, well, first you need to have the numbers. So you need to search for the numbers. Then you need to crunch them. So you need an algorithm. You need a procedure to crunch them. What else? What do you need? You have the algorithm. I tell you, look, this is an algorithm. Here it is. Can you do this?
No, I need computer power.
You need a machine to run the algorithm on. And then I give you this. Look, I unplug my computer, I give it to you, and it says, okay. I come to you and I say, can you tell me what is the risk factor?
No, I need time.
I need time. I need a procedure. I need time. And I need infrastructure. Materials, resources. Okay? If I have these things, I can use them to try to take a situation of uncertainty, i.e., I don't know the probabilities, but I know that they are out there. I know that these are the probabilities. I just need to find them. I can use time, I can use resources to find them. To try to converge to finding these probabilities, to reduce the margin of uncertainty. So, now please don't disappoint me. Who here plays Dungeons and Dragons? At least one person, otherwise I walk out and tell. Okay, at least one person. Okay. So, just one person? Really? Only one? I need, okay, another one. Okay, come on, okay. There's a bunch of nerds in the class of computer science. Look, in the EAT digital class, there is not even one single person that does this. It's very disappointing. There need to be nerds in the world. Nerds will save the world, okay? So, when we play Dungeons and Dragons, there is a classical roll of the die, which is called the armor class check. Okay? You know where I'm going to? People that play Dungeons and Dragons? So, Dungeons and Dragons is a role-playing game that you play around the table with pen and with paper. We'll actually might play this next month together. For those of you that want to do this. It's research, by the way. We'll write a paper about this. But we sit around the table. There is one person which is handling the game, and it's called the game master, and there is a number of players. The game master represents the world. He knows everything about the world. He is the ultimate person that decides what happens in this world. The players are actors in this world. The players will sometimes find monsters that they need to try to attack. They will roll a die. If the roll of the die is high enough, they will succeed. If the roll of the die is low enough, they will fail. The players don't know what numbers they have to get, because only the game master knows it. So they are in a situation of uncertainty, textbook situation. They can invest time and resources, their turns, to roll the die and get a number. Once they will get a number, they will have a better estimate of what number they have to take on the die. So, I roll the d20 and I get 17. And the game master says, success. How does the player update their knowledge based on this?
I have a question.
Yes.
The number stays the same?
The number stays the same. Very good question. The number stays the same. How does the player update their knowledge after seeing that a 17 is a success?
They have a boundary.
They have a boundary. The boundary is that anything from 17 up will be a success. Okay? So the next player rolls and he gets a 5. And now they know that the 5 is not enough.
The two policemen theorem.
The two policemen theorem. I have an upper boundary and a lower boundary. If I have an upper boundary and a lower boundary, the result must be in the middle. Right? So as the players invest their resources, they will narrow this margin of uncertainty, ideally with infinite time, to one specific number. They might see that 11 is enough, 10 is not enough. But the situations might interrupt before, and the uncertainty might still be there. And they just might be left with an approximation with two limits and two margins of uncertainty. So, uncertainty requires a more complex decision making. And the decision making of uncertainty is what is called procedural decision making or bounded decision making. Bounded by resources. Procedural because it requires a procedure to be taken. And the procedure works as a loop. I have a preference and an aspiration level. So the preference is I want to hit the monster. An aspiration level is please let me roll at least a 10. I roll and I get 5. I gather information and I get an action, which is I try to do this, and I get a consequence, uncertain. Is 5 enough? No. Let's change my aspiration level. Maybe I will get an 8. Maybe the 8 will be enough. Let's try again. I get 9. It is enough. Okay. And I can keep looping at this until I narrow down enough the uncertainty, or more likely, I finish some of my resources. My time, my money, my brain power, my CPU capacity, my hard drive, whatever. I finish some resource. So, the solution is out there, but I need to spend time to find it. What does this remind you of in computer science? The solution is out there, but I need to spend time to find it.
Crawling.
Web crawling? What else?
Mining.
Sorry?
Bitcoin mining.
Bitcoin mining? What else?
Any optimization.
Sorry?
Any optimization.
Any optimization, literally any algorithm ever, right, is this. So this, the procedural rationality, is the key epistemological tool of all computer science. Procedures that use limited resources to dissipate uncertainty. Okay? Let's take a break We started a bit late, so let's have 5-10 minutes. Then we come back here and we have a truckload of examples to dissipate the uncertainty. Okay? Vedo differente. Però qua si parla di cose.
But it's not overstaying the last 8 The readings will be published on the website. One of them is here, reading. So this would be, maybe I put mandatory reading.
And so, first good source is look at the slides, and the notes and the notes from that are very good. But specifically on these and some other topics, there are mandatory readings. So for the exam, you need also to read those. These are papers or books.
Well, if it's books, if it's a lot of books.
No, there's not books.
I think it's papers or full books.
Yeah, papers, practitioner articles, they're not full books.
Okay. And about this report, when I will hear about the report, like what's happening?
Probably next week, but you can look at the website of the past year. You can find there the assignment guide for the past year. It's going to be the same for this year, except with different themes.
How, like, what is the website for the past year?
It's the same as the one of this year, but with 2018.
And approximately exams are in January or?
One in January, usually in, let's say, the first half, and the second one the first half of February.
Okay, so for non-attending and attending students,
Yes.
exam will be on the same day, written exam?
Yes.
Okay.
You're welcome.
Però magari si vuole prendere lo Skype per fare tanto scrivere una cosa
Okay.
We start.
So, first of all, just a side note, I updated this slide here, and the version that you will have will be the same. Here it will say mandatory reading, to underline the fact that for non-attending students, this is the only mandatory reading of basically the whole class. Okay? So, we put here a brief reference, let's say, and then all the readings will be also on the website. We have already all the PDFs. We will send them to the webmaster, and as we send them to them, they will appear on the website. Okay? So, we spoke about uncertainty. We spoke about this idea of procedural rationality and of procedural bounded rationality. So now let's try to give examples of this. Let's try to give examples of this procedural thing of refining results, of refining things to converge to an optimum using resources. And let's look for these examples in the field of innovation. Any innovation that you want, let's talk about procedural innovation in some sense. What are examples of procedural innovation according to you?
So the examples, the things that were created iteratively?
Yes. Yes. Things that are created iteratively, of course. Examples of some of So this is the Samsung S8, I think. What is this? This is called S8. What does this tell us? Yeah, there was an S7, an S6, an S5, and so on until an S1. Okay, so this has been improved, right? The core thing is the same. It is still a smartphone with that type of operating system from that manufacturer and so on. But it has been iterated multiple times. Is it the perfect cell phone? The S8? No, why? Otherwise there wouldn't be an S9, right? And it is good business sense to make space for an S line, but also an S10, 11, 12, and up until the end of the natural numbers. Okay? So it is a local optimum after spending a certain time of resources. A certain time of resources, which are time, money, dev manpower, natural resources to build these things, factory, assembly line, and so on. What are other examples of this procedural in innovation?
The price setting online.
Sorry?
The online price setting.
Price setting online. What do you mean?
Because you try to find an optimum, min or max, using the data you collect from the concurrent.
Okay, so if I want to sell or buy a good, the price that I will want to set for me to buy or for me to sell will be following the same thing. I will start from a guess, then I will look for some data, and I will update my guess and keep updating till eventually I either reach the end of times or I just reach a point in which I say, okay, this is good enough. This is what Simon calls satisficing. This is good enough. I can put it there for sale, or I can buy this. So for example, if I'm trying to buy the SD cards in the media world, which is a classic type of this decision, I go around the media world, I find SD cards in the photography department, and they cost something. Then I find them in the cell phone department, and they cost something. And I can choose. Either I have reached an optimum here, so I pick one of the two, or I keep searching. I find a third, I find a fourth, the fifth, and then the supermarket closed and I'm still there. But hopefully I reach a decision. Okay? Other examples of this innovation?
Machine learning also models, for example, Bayesian networks or deep neural networks.
Yes. How? Machine learning networks and, machine learning models in general, how do they do this?
They start from a random guess of parameters and they try to optimize them based on data set.
Okay, you start from this is especially, I guess, unsupervised learning. Supervised learning, unsupervised learning. So what you are saying is, I start with a random guess of the weights of the neural network or of the parameters of a model or whatever. I see how it performs based on the data. I try to adjust, and I keep repeating this till eventually either I train until the end of times, and what I reach is called overfitting most of the times, which means it will work perfectly on my data set, but it will not work very well in general. Or I say, this is good enough. I can take this estimate. These are my parameters. I assume these to be my parameters, and I try to see if I can predict also the future up to a certain point. Okay. Actually, you are skipping to the next slide, but we will get there. So, no, because I'm going to do the same thing. Examples, innovation, in business, and in ICT. So we have seen one example in ICT, which I think works very well. Let's see also example in business and also in ICT. Up to you. So examples of procedural rationality, or procedures of these type of things. What about looking for a place to go in Erasmus? This is also the same. Because if I need to exhaust and to search everything to get the perfect optimum, I will never go on Erasmus. I will keep searching for universities for 2 years. Instead, I need to go, get some information, and say, well, maybe this is good enough, and settle for this. What about office procedures? the same. I need to process a piece of paper or a piece of bureaucracy. I make it follow the normal pipeline. Oh, there is an exception. Okay, it exits from one pipeline, it enters the other. And it follows that assembly line till eventually it is processed, or it becomes something that we have to tweak manually and create a special case around. So we cannot find exactly where it fits in the decision. What are other procedural bounded things? So let's take the dating example, which is good enough for these things. How many of you think that there exists for them only one person in the world to which they are destined to meet and be forever happy together? How many of you don't think this is the case, and there exist multiple people for which they will be happy to somewhat survive? What about all the rest? No, I'm interested to hear your there's nobody who thinks that there's nobody in the world. This is very grim and sad. Okay? But, okay, either nobody or one or multiple, you should have an opinion on this. I suggest you form yourself an opinion on this. But the point is, more likely, there is not one person for you in the world. Maybe in the Middle Ages, where you were limited to a small circle of people you would get in touch with, there was only one person in the people you would meet in the space of one lifetime. But right now, the world is relatively big. There's 7, 8, 10, whatever billion people, right? Very hard to think there of the 7,999,000,000 and so on, there's only one. You can search for a partner, and eventually you, according to your procedures, your preferences, your aspiration levels, so you follow the thing that we saw before. You update your preferences, you see how they go, till eventually you settle on something which you say, okay, good enough. Most likely, you will not follow this procedure though. You will not have a procedure to find the optimal partner. You will use another type of reasoning. You will use other parameters, which is not just a matter of optimizing something till you find the Nash equilibrium, okay? We will see next time examples of this. Okay, other examples? Procedures? Bounded decisions? Okay. So, key points, once again, are the limited resources and the convergence to optimality. So, we are saying that we don't know if we have enough resources to reach an optimum, but we most of the times do not have them, but the optimum exists. The truth exists. The first definition of epistemology that was given before, that it is the philosophy of truth and of facts. Here, our epistemology still says that there is a truth, that there are facts. Undeniable facts. Truths in the world, we just need to spend time to find them. Is this always the case? Is there one truth in everything? Not so much. So, let's look. We have seen these three models. Okay? We have seen certainty, we have seen risk, and we have seen uncertainty. So now let's break things. Let's do unit testing. Okay? And let's look for points of failure of all of this. And I've highlighted some of them here for you. One was the one that was said before. Was it here or here? On hasty generalization. Assuming that we are in certainty. Was you, right? Yep. That was saying, we assume that we are in certainty, but actually we are not in certainty. What happens here? What happens if we assume that we are in certainty, but instead we are not? This is for everyone, of course.
It depends on the problem.
It depends on the problem, of course. But can you give me an example where you assume you are in certainty, you are not, and it turns out to be a problem or not to be a problem? So let's discuss this scenario a bit.
If
Everyone.
I have a company and I decided to always invest the 10% of my income, supposing that I have the certainty of a growing constant. But this certainty is wrong. I can invest more money than what I can, so my company risk to fail.
Okay, so if I'm certain that I'm going to grow, and I'm going to invest money in growing, buying new buildings, hiring new people, making more products, selling them to more people, having more clients, which tell me that I need to have more salesmen, more HR, more buildings, more office, more. I keep growing. I think this is certain for me. I take this for granted. Okay, so you know what? Next year, since we grew we always grow by 10%. Next year, we have reached a point where we need to buy a new country to hire the next 10%, to grow by 10%. We buy the whole country, we spend 400 quadrillion millions, and now we can't grow anymore. So, that investment is completely pointless. And I made myself so much debt that now I'm unable to move out of here. I assumed I was in certainty, I was not. Other hasty generalizations of assuming certainty? Well, we have seen one together. There was the Popper's turkey. Have we seen it? We did? Right, yes, we did. Induction fallacy, every morning the farmer goes and feeds the turkey. The turkey thinks that every day the farmer goes to feed him. One day is Thanksgiving, the farmer comes, kill the turkey, chow turkey, dead. Okay, this was a hasty generalization. Assuming certainty, it is not certainty. Actually, it is still certainty in the sense that it is certain that the turkey will be killed on Thanksgiving, but the turkey doesn't know it. But this is another induction fallacy. Assuming certainty. What are other situations? Examples where certainty was assumed, but it turned out, it wasn't.
2008 crisis.
The 2008 crisis, exactly. Can you tell me why?
Yeah, they thought that the market of
yeah, this was the real estate market. This was the
market will go.
Lehman Brothers was the first bank that collapsed, but it was the subprime loans. Subprime loans. They were assuming that people will keep using these type of loans to keep buying new houses and keep going on this expansion and growth of the real estate market. Suddenly, this doesn't work anymore. It causes a huge crash. So, since we are at this point, and this was exactly one of those that I was hoping would come out, I want to show you one of the limits of this. So far, one of the things that we have not really been able to find a critic of is that risk implies reward. And therefore, there should be also in some sense another implication. Most of the time, the fact that there is a reward implies that there was some risk somewhere. So, think of gambling in general. Let's say I have a very big die with 1,000 faces, right? Which I am able to roll every minute because it's very big, so I need to lift it and roll it. We make a bet with you, and we decide that if anything but one comes out, you win how much? If I want to make a fair bet. If anything but one comes out, you win 1,000 faces. If one comes out, how much do I win? Sorry? 1,000. Which was 1,000 faces. Are you with me so far? Probability? Okay? So, lots of possible spaces. If you go for the safe bet, the reward is low. If you go for the risky bet, the reward is high. But the fact that the reward is there tells you that even the safe bet is risky. If you go to the crisis scenario, the fact that you are expecting the market to always grow tells you one thing, that somebody is betting on the market to crash. because otherwise there would be no reward for growing. Does this make sense? So, what happens when the growth starts becoming smaller and smaller and smaller?
People get scared.
People get scared because it means that the crash is approaching. So, this is one general big observation that we will go much deeper into the next time. And we will be talking about the fact that risk and reward are always there. So far, at least, in our macro society, in our macro system. Risk and reward are always there, which means that if I take my machine learning models and I keep refining them, I'm doing two things. And I keep developing the whole world. I'm doing two things. The first thing is I am increasing the number of sides the big die that I roll has. I increase the number of faces, which means I reduce the probability of hitting the one. I make my bets safer. On the other hand, I also increase the amount of times I roll the die every minute. So, balancing the equation here becomes tricky, because increasing the number of faces of the die, aka making the things safer, means that when the one will come out, we will be much more screwed. And if I increase the amount of rolls at a faster velocity than the one I am increasing the number of faces of the die, this is not a very nice outlook. It's not going to end very well, right? So, risk implies reward. And most of the times, the fact that there is a reward implies that there is a risk. So, keep this there. Because this is what creates risk aversion. What is risk aversion? So, let's do it like this. We change the rules of the exam, and the exam is 40% of the times I will give you questions on what we're talking about in this course. 60% of the times I will give you questions about what they're talking in the history of art course of Ca' Foscari in Venice. Would you be willing to do this? Well, does some of you know at least a bit of history of art? A tiny little bit? Who is Leonardo? Maybe you know this, right? The Gioconda was painted by Leonardo. So you know a tiny little bit, but you still understand that there is a big risk involved into my proposition. And your general understanding is to be skeptical of that risk. Risk aversion. You are afraid of risk because you have no certainty. So, when is risk aversion a fallacy? So let's do a bet, and the bet is that, I don't know, we flip the same, we roll the same die. Okay, I played the game with the gentleman in front here, and 4 times, 1 to 4 you win, 5 and 6 I win. Okay, is this bet good for you in general? 1 to 4 you win, 5 or 6 I win.
Yeah.
Yes, in general it is good for you. But let's say you only have in your whole bank account €1. This is all that you have, and each bet costs exactly €1. Are you willing to take this? Yes, you would be willing still 40% of the times. Because, no, sorry, 2/6 of the times you would be willing to lose this? It's your last €1. No, you would never do it. Because you see that there is a risk. And you are averted from it. So one of the risk aversion becomes a fallacy when I have limited resources, because I do not trust my rational behavior, which is the one of saying this is a winning bet, I should put it to this, because the stakes are too high. And you say, I need to distance myself, I cannot take this risk. So maybe you would want more faces of the die, right? Or the die to be, or you would want a bit more resources to spend, and then you would be willing to take this. And what about uncertainty intolerance? What is this about? So let's stick to the exam. You know that there is going to be an exam in the end. You know, and we told you that there will be 2 questions, we will be able to choose one of the 2, blah, 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 15 points, blah, blah, blah. Okay? So now you are fairly tolerant of the uncertainty that you have in front of you, which is which questions are going to be on the exam. Right? However, if we just told you, we will have an exam in the end, don't worry, how would you feel? Much more skeptical. You would want more information because the uncertainty is too much. And you instinctively do not tolerate this uncertainty, which is too big for what you think is at stake. So what is a behavior to adopt in a situation where you are faced with uncertainty and you are not tolerating it? What are possible behaviors to adopt? Possible solutions, possible way out of this. Yes? Ask questions, gather information, and reduce the uncertainty to a level which is below my intolerance threshold. What are other options? So, you are at the exams of innovation and business in ICT. Okay? Can you reasonably assume that the exam will be about innovation and business in ICT and not history of art? Yes. So, one option is, can you tell me more about how the exam works? And we can tell you more. What is the other option?
Go at the exam.
Sorry?
Go at the exam.
Go at the exam and find this out. But in preparation, what is another option?
No, go at the exam and then see the question and go to the other.
To the next one. Okay. So you are lengthening the time span. Let's say there is only one try. You want to reduce your uncertainty. What can you do?
Learn everything.
Learn every damn single thing, right? If you are prepared for everything, you are also prepared for anything. So whatever the instance of the problem you will find, you will be ready for it. Okay? So you can raise your threshold for uncertainty tolerance. You can reduce the uncertainty or you can raise your threshold. What are other options? Keep in mind 2 things. You invested resources in both cases, because whether you study hard or whether you expose yourself in the class to ask a question, you are still investing a resource. Are there ways out of uncertainty intolerance without spending resources?
Wait for others to ask.
You wait for somebody else to act. You invest your resources somewhere else, and you wait for someone else to invest their resources into this. Yes?
Yeah, but this is a risk because
This is a risk.
If no one asks.
So what happens in this case if you are waiting?
Lower your probability of.
You spend time.
You are implicitly still spending time. You are using that time somewhere else, but you're implicitly still spending it. Your resource is still going to be limited and is going to be even more limited later. So if someone else then asks the question and the answer comes out to be one for which you are not prepared, well, you cannot help too much because it's too late. So having somebody else dissipate the uncertainty for you can work, but not always. Other things to deal with uncertainty, and this, yes?
Yeah, maybe trying to guess what are the most probably type of exams, because you know the professors and you think, okay, maybe this kind of professor can be thing kind of.
You can guess. You can look at the past. You can spend time researching this and do some sort of a specialized machine learning for this case.
Yeah, maybe trying to guess from the lecture and say, yeah.
From the lectures, from the past exams, from asking other people. So you don't directly, you can choose to spend your resources to get indirect benefits that still work towards this. Okay. There is also another point. We are talking about optimums, but there are different types of optimums. I just want to tell you two optimums that exist without giving you a formal definition. Then you can look them up for yourself. We will not ask you about this, but I just want to tell you two optimums. The first is the so-called Nash equilibrium, and the second is what is called Pareto optimality. Has anybody heard Nash equilibrium? Raise your hands. Okay, Pareto optimality. Oh, okay, this is interesting because actually a lot more people previously knew about Nash equilibrium and not Pareto optimality. So can you help me with having broad definitions of this? Starting from Pareto optimality, it's okay. So when is a state of a system Pareto optimal?
Right, when you want to optimize two variables. So if you want, I don't know, to have a good lunch, but also not to spend much. So you find a solution in between those two.
Okay, so you're optimizing two variables. For example, money spent for a lunch and quality of the lunch that I will have. And I want to find an equilibrium between the two of them. But Pareto optimality has one more constraint. So this is the general setting for trying to find an equilibrium. How is Pareto optimality defined?
I think that there are many solutions which are kind of equal.
Okay, so let's say I have these two variables. There are many solutions that are equal, which are potentially equal, agree, but there is one key factor of these solutions. What is it?
That the solution should dominate at least in one variable.
The solution should dominate at least in one variable, yes, but not necessarily. There is one key point in Pareto optimality, which is that I have the overall score, okay? If I decrease one, I should increase the other by an amount that at least keeps the overall score at the same level as before. You see what I mean? What I'm saying is, if I'm quantifying the quality of a meal in, I don't know, still euro, whatever, and I'm quantifying the expense of a meal in euro, if I'm adding 1 euro to the cost, I need to get at least 1 more euro in value. Otherwise, I'm not Pareto optimal anymore. What about Nash equilibrium? Is it so far? Are you with me?
What?
Are you with me on this?
Yeah.
Okay. Guys, if there are mistakes or if you think something is not fair, you should point it out. Silence. Nash equilibrium, what about this? So the classic example of Nash equilibrium is the prisoner's dilemma, right? Two prisoners, they can choose, well, let's take an even simpler case. I'm playing with somebody else and I have two buttons. One button says defect, one button says cooperate. Okay? If both people press defect, they all get 1 euro. If both people press cooperate, they both get 2 euros. If one person press defect and one person press cooperate, the person pressing cooperate gets 0, the person pressing defect gets 3. Okay? So, 2 defect, €1 each. 2 cooperate, €2 each. 1 defect, 1 cooperate, defect gets 3, cooperate gets 0. This is the prisoner's dilemma. The trick is, the 2 actors cannot speak to each other. What do? The Nash equilibrium is that state in which every actor chooses the outcome which is the best for himself. So, if I defect, I get 1 if we both defect, and 3 if only I defect. Okay, so I can get 4 at most. In the cooperate, I get 2 if I cooperate, and 0 if the other person tells me defect. Here I can get 4, here I can get 2, I always defect. Nash equilibrium. I do what is best for me. Okay? I go wherever the stakes are higher. I go wherever I can expect to get the most, playing selfishly. So the definitions of optimum are different. In uncertainty, different definitions of optimum tells us different strategy. Some definitions of optimum will tell us that there is no strategy. This will happen many times, and we will see next time what are these situations. The law of big numbers. I always expect to win in the long run, but what if the long run doesn't come soon enough? I am screwed, because of the situation before. I'm going to risk aversion. And finally, there might be unknown unknowns. There might be parameters of my machine learning model which I didn't even know would be parameters. So I'm making the perfect model, but I'm not looking at the fact that there is one more parameter which I have not labeled, which is not even to be considered, but should have been there. So I might have unknown unknowns. How do I address them? I cannot do this just with procedural rationality. Okay, so this is a big salad of concepts. To fixate these, let's just look at one example in practice. Let's look at the roulette. And we will make a roulette for each of the 3 main models that we saw today: certainty, risk, and uncertainty. So, we go to a casino. At least one person that played Grim Fandango. Do we have it? Thank you. Two people. Fantastic. Okay. 3. Okay, fantastic. We have at least one person that played Grim Fandango. So, Madame et Messieurs, faites vos jeux s'il vous plaît. Ladies and gentlemen, this is a scene in Grim Fandango. Okay, this is the croupier. There are 3 tables, and the croupier is going for each table and doing the roulette. Okay. So, the roulette of certainty. How does the roulette of certainty look like? A roulette where I always win or I always lose. How does it look like? Yes?
There's just one number.
There's just one number. It's all, I don't know, black 4. Okay? Easy enough? All agree so far? So, the roulette of certainty, every tile is the same number and the same color. So I know that if all numbers are black 2, if I bet on black, I always win. If I bet on red, I always lose. If I bet on 4, I always win. If I bet on non-4, I always lose. Difficulty of decision making, 0. Actions have necessary consequences. Ciao. Let's look at the roulette of risk. How does the roulette of risk look like? A normal roulette. It's a normal roulette, which is fair. It has colors, numbers, I can bet, and I have probabilities. I know how many times I win, I know how many times I lose. Just your roulette. Finally, how does the roulette of uncertainty look like?
There's no numbers.
There are no numbers, but what happens in uncertainty? Spending resources, I reduce the margin of uncertainty and I reach the truth. So what is happening? There are no numbers, but
after one spin, you can see the number that went.
Exactly. After one spin, you can see the number that came out, and maybe all the numbers are covered, right? And after every spin, I remove the cover, and I see it. Okay? But my players of Grim Fandango know that in this puzzle, there is one feature. Okay, who wants to play Grim Fandango in the next future? Okay, you want to. Can you tell me what is the key feature of Grim Fandango in this situation? How does this puzzle solve? You remember? You go upstairs in the office of Manny Calavera, which is the protagonist, which is this guy here. And Manny Calavera has a control system through which he presses a button and he chooses where the ball lands. Right? So he can manipulate the roulette and he can say, now a 4 comes out. Okay? So, is this certainty, risk, or uncertainty? It's certainty, but from the point of view of the person that is playing the roulette, is it uncertainty? Is it certainty? It's an unknown. They cannot know, and even if they spend all their resources, they cannot know what the decision-making process is, as long as Manny Calavera presses the button enough to confuse them enough, or following his own agenda. Sorry, spoiler, in the end you did not follow the instructions good and well enough. Okay? This is not certainty, is not risk, is not uncertainty, is the topic of the next lecture. What happens beyond this? And these will be our keywords. Post-truth, the unreal, subjectivism, social construction of reality, postmodernism. It's going to be another huge salad of different concepts. So, next steps. Monday?
Monday.
The battle preparation is at?
I think it's 1:30.
You will receive an email from the housekeeper, right? Group number 4 will have their battle preparations. So check your inbox if you're in group number 4. And then lecture at 2:30 still here with the battle.
Yeah, there is the battle.
Battle number 2.
Yeah.
Okay? As always, questions and whatever, go here. Anything else to add?
No.
Ciao.